Okay, so hello, good day. Again, I'm Engineer Ernesto C. Prudenciado Jr. and welcome to my channel. So, we are going to continue with our topic in engineering mechanics, no? So, we are now in dynamics and we already discussed uh, uniform velocity or constant velocity, okay? So, we will move on to the new topic, constant acceleration, okay? So, beforehand, we will derive first the formula and the equation involved in dealing with constant acceleration problems. So here we go. Okay, so we are given this basic formula. Velocity equals distance over time. Okay, and also acceleration is equals to velocity over time. Okay, so if we will graph this, no, recall your analytic geometry. So you can have this. This is your D and this is your T. Okay, this is your V and this is your T. Okay, so the slope here should equal to B, and also the slope here should be equal to A. Okay, so this is now our formula represented by a graph. Okay, if I will cut a small portion here and also here, so I can have here as ds and dt. Okay, this one is dv and dt. Okay, so this is now called the instantaneous velocity or instantaneous acceleration in this case. Okay, so we now have v equals ds over dt. Okay, and acceleration or a equals to dv over dt. Okay, so if I wish to get the instantaneous velocity, I will just have to integrate this term. Okay, so rearranging first, dt a equals dv. Okay, so a here is a constant because we are now in constant acceleration. So I can integrate this. So this becomes a t equals v with limit 0 to what? Time, final time is t, velocity initial and velocity final. Okay, so this will be what? A t, so because t substituted by 0 is just 0, so what remains is t final equals this one, velocity initial minus velocity final. Okay, so rearranging this, this becomes v final equals velocity initial plus at. Okay, so acceleration times time. Okay, so sometimes our problem deals with deceleration, meaning from a high speed going to low speed until it stops. So that will be deceleration. So the general term, I will just replace this by plus or minus. Again, plus for acceleration, minus for deceleration. Okay, so this will be our equation 1. Okay, so take note that our formula involves velocity, acceleration, and time. Now, if we wish to include the distance from our expression, we will just substitute the instantaneous velocity, to this expression. Okay, so what is the instantaneous velocity? So this will be ds over dt, equals to velocity initial plus or minus acceleration times time. Okay, so cross multiplying, so this becomes what? Vo dt plus minus at dt. Okay, so integrating all the terms. Okay, so this becomes what? S equals, so velocity initial in this case is constant, so that would be VO t. So plus or minus acceleration also is constant, so this becomes power formula, no? So t to the n, where n is 1, so t squared over 2. Okay, so with the limit of this one is 0 to 1, 0 to final S, and this one is 0 to time final. Okay, so this remains S VOT plus or minus acceleration plus or minus 1/2 AT squared. Okay, so this is now the formula number 2 to be memorized. Okay, so again, no, formula number 2 is just came from formula number 1. So we are just expressing the formula in terms of distance. Okay, so very easy. So from instantaneous formula, we can have also the expression, no, in terms of dt, because dt is common here. So we will rearrange this in terms of dt. So in the first equation, so dt equals ds over v. No? So in the second equation, dt is equals to what? dv over a. Okay? So we can equate this one, ds over v over dv over a. Okay? So this will be a ds and v dv. Okay? Okay. So the purpose here is to get rid of dt, or to get rid of time, no? So if we want to get the final expression, no? So if we want to get the solution of this expression, so we will integrate this. Okay? So this becomes a s with the limit of 0 to final s equals to this one becomes v squared over 2 with the limit of velocity initial to velocity final. Okay? So the final term here is as, no? Because 0 here is 0, so s will remain, equals to, this one becomes what? Let's factor out 1/2. Okay? So becomes what? Velocity final squared minus velocity initial squared. Okay? Further rearrangement, so 2as equals to velocity final squared minus velocity initial squared. Okay, so velocity final squared equals what? Velocity initial squared, no? Plus 2as. Again, if we are dealing with deceleration, we must put this as minus. So the formula becomes plus and minus 2as. So this is now the formula, or the third formula to be memorized. Okay? So that's it. So in summary, we have this formula. Formula to remember. Okay? So one is velocity final equals velocity initial plus or minus acceleration times time. Okay? So number 2, velocity s is equals to velocity initial times time plus or minus 1/2 at squared. Okay? So number 3 is velocity final squared equals velocity initial squared plus or minus 2as. Okay? So these are the 3 formulas to remember. Okay? Nothing else. So we can deal now with dynamics. Okay? So tip lang, no? If you want to examine the formulas, if the unit are consistent, so we will check, no? So here in formula number 1, BF, so velocity, so meter per second. So velocity initial is meter per second. Acceleration is meter per second squared multiplied by time, which is second. So the 1 unit of time at the bottom will just cancel out. So the remaining here is meter per second. So this is consistent with our formula. Okay. So here for formula number 2, S, so distance, no? So it might be in terms of meters or feet or kilometers. So let's examine the term. So VOT, velocity is meter per second, times time. So cancel out the seconds at the bottom. So meter. So correct. Next is 1 half AT squared. So A is acceleration of meter per second squared. So times squared, no? Times T squared. So cancel out the second squared at the bottom. What we have left here is meters. Okay, so correct. The third one is BF squared, so meter squared over second squared. So this is already correct. 2AS is acceleration meter per second squared times meter, so meter squared over second squared. So this is also correct. So that's one way to memorize, no? Because sometimes, no, as time goes on, so you will forget what's the right term, no, or what's the formula. It will happen that it may interchange, no, in your mind. So this is one way to check whether your formula is correct, no, to examine the units. Okay, so take for example this. If you will forget number 2, no, you might thinking maybe that is 2 acceleration time squared. Yeah, it is also consistent with the unit. But take a look, no, this is integration. So the integral of u to the n is u to the n plus 1 over n plus 1. So this denominator is just equal to the exponent of t. Okay? So that we will consistent with our integration. Okay? So that's one way to remember these formulas. Okay? So let's go now to the problem. Example problem number 18. What is the acceleration of the body that increase in velocity from 20 meter per second to 40 meter per second in 3 seconds, no? So answer in SI units. Okay, so what are the givens? So velocity initial is 20 meter per second. So you know that this is velocity because meter per second. You will not interchange it to acceleration because you know the unit of acceleration is meter per second squared. Okay, so that's it, no? So beware of the units lang. Be familiar with that. Okay, so velocity final 40 meter per second. Okay, so this is acceleration, no? Because the speed is constantly increasing. Okay, from 20 to 40. So time is equals to 3 seconds. Okay, so what is the acceleration? Okay, so first, what I have to do is to write all those 3 formulas first. So first formula is velocity final equals velocity initial plus or minus acceleration times time. Number 2 is velocity final or S is equals to velocity initial times time plus or minus 1 half AT squared. Correct? So number 3 is velocity final squared equals velocity initial squared plus or minus 2AS. Okay? So given time, given velocity, we can use this expression. So by inspection, no? So it's very easy. Direct substitution. So the solution here is VF equals VI plus or minus acceleration times time. So BF here is given 40. Be consistent with the unit, no? Meter per second. This is 20. We will use plus because from inspection, this is acceleration. So A times time. Time is what? 3 seconds. Okay? So consistent naman sa unit. We can solve acceleration equals what? 40 minus 20. Okay? Over 3. So this is 6.67 meter per second squared. So this is your final answer. Okay, so let's go to problem number 2. From a speed of 75 kph, a car decelerates at the rate of 500 meters per minute squared along a straight path. How far in meters will travel in 45 seconds? So let's write first the given. Okay, given. Okay, given is from the speed of 75 kph. So given velocity initial 75 kph, no? A car decelerates, so acceleration is 500 meter per minute squared. Okay, so but this is deceleration, no? So we will just use the negative formula later on. Okay, so the time is 45 seconds. 45 seconds. So required here is the S, or the distance traveled. Okay, so for us to be consistent with our unit, so we will convert this into meter per seconds. Okay, so kilometer is equals to 1,000 meters. Okay, so cancel kilometer here. So next is hour. 1 hour is equals to 60 minutes, and 1 minute is equals to 60 seconds. Okay, so cancel hour here, minutes. So what we have here is meter per second. Okay, so we will solve now using our calculator. So that is what? 75 times 1,000 divided by 60 divided by 60. So 20.83 meter per second. Okay, so acceleration, we will convert this also into meter per seconds. So the problem here is just the minutes, so we will easily convert this into seconds. So this is squared because minutes squared. So what we have here is 500 divided by 60 squared was 0.1389 meter per second squared. Okay, so the solution, we will first write the formula, no? The three formulas given. So number 1, velocity final equals velocity initial plus or minus acceleration times time. Number 2 is S, velocity initial times time plus or minus 1/2 AT squared. Okay. Number 3 is velocity final squared equals velocity initial squared plus or minus 2AS. Okay. So we now have two formulas involving S, no? The formula number 2 and formula number 3. So by inspection, so given time, we can use the formula number 2. But because in formula number 3, we don't have velocity final. By the way, no, this is velocity initial. Okay? So VIT plus or minus 1/2 AT squared. Okay? So we will use this formula number 2. Okay? So substituting, S is equal to, what is our velocity initial? That is 20.83. Okay? Times time is 45 seconds. 45 seconds. No? So deceleration, we will use the negative 1/2. Deceleration is 0.1389. Okay? So time is 45 seconds squared. Okay? So S is expectedly in meters. So 20.83 times 45 minus 1/2 0.1389 45 seconds. So the answer is 796.71. 796.71 meters. So this is the distance traveled, no, by a car. Okay? Okay, so thank you for listening. Hope you learned something from me. And let's continue our topic next meeting. Bye.